Hi, Benjamin from Eclipse. Today I wanted to show you how to connect this guy, the TI CC3200, to the internet using MQTT and especially Paho, the Paho embedded C client. So what we're going to do is we're going to use one of the basic examples that come with the CC3200 and tune that so as we actually can send sensor data to the internet, and the other way around. We also want to be able to push commands to the board to say blink an LED. So it's going to be a two-step process. First we want to publish data, and then we want to subscribe to a server and be notified whenever commands are available for us. Now, why are we doing this? Well, reason is simple. This guy is capable of Wi-Fi. That's great. We can connect the board to the internet. But what we want to do is actually be able to control the board from wherever we are in the world. It's not only because this guy is connected to the internet that we're going to be able, from say our smartphone, to talk to it, right? So what we want to do is use MQTT so as we have a central broker that is a server on the internet that we can connect to, and not only the board will be connected to the server, but also a mobile application can be connected as well. So as if we want to talk to a specific board, we will exchange messages, send messages to the broker on specific topics, and this is basically what we're going to do. So hopefully over the course of this very quick tutorial, not only will you be able to actually use MQTT, but also if you're not very familiar with it, you will be able to understand what it does and why it's important for the Internet of Things. So without further ado, let's open Code Composer Studio on my Windows machine, and we're going to write our first MQTT piece of code, which is going to send the temperature. There is a built-in temperature sensor on the board. We're going to take this value and publish it on to an MQTT broker. So let's open Code Composer Studio now. All right, so now, as I said, we open Code Composer Studio and we're going to use the out-of-the-box example. If you're not familiar with that example, well, it's the one that, when it's properly configured, allow you by opening your browser to access some demos. So this is actually the IP address of my Wi-Fi CC3200, and yeah, we can access lots of examples, and the source code of these examples is actually here. I imported the OOB project in my workspace. Now what we're going to do is change and improve this main application so as it uses MQTT to, as I said, we're going to start by sending temperature data. We want every second, we want to send the temperature data to an MQTT broker. So what we want to do first is retrieve the Paho embedded client. So we go back on the internet. So eclipse.org/Paho is the homepage of the Eclipse Paho project, right? So what we want is use the C embedded client, and on this page you have basically everything you need. The URL of the sources, as well as a small code sample that we're going to use in just a minute. So this is the URL of the Git repo. I want to copy this address so as in the Eclipse, what I want is actually import the project from Git. I want to use a URI to clone. It's on in my clipboard, so automatically this is filled out. All right, there is actually a branch, a Git branch on this repo. Perfect. I want to import the code, clone the code, and then import the code in my workspace. Right, so I now have an Eclipse CDT project corresponding to Paho now, and this is the sort of tricky part. Unfortunately, Code Composer Studio doesn't allow me to convert a legacy Eclipse CDT project into a proper Code Composer Studio project. So we're gonna need to do some nasty stuff so as the sources of Paho and of MQTT are properly mounted in the OOB project. So first thing I want to do is take all these sources in the MQTT packet/src project and drag them. I'm also pushing the control button, so as it's actually a copy and not a move that happens behind the scene. I want to copy the sources and actually know I want to link them in the OOB project. All right, so now hopefully I will be able from main.c to actually do things like including MQTT related stuff, which is exactly what's happening now. And what I'm going to use is MQTT packet.h. Now I can save the file, and it won't compile if I try to build my project. It won't build just now, because, and this is where again it's quite ugly, I must confess. I need to do one more thing, is go in the properties of the project. In the build on compiler include options settings, I want to add sources that are actually in my workspace. I want to add this folder so as it's properly included, and when I will build my project, it's gonna work. All right, so I'm ready to actually use MQTT and Paho now. What I want to do is have a look at the main. What's happening there? Well, some initialization of the board, configuration of the GPIOs, initialization of the temperature and accelerometer sensors, and then there is a task. You know, there is an RTOS in the CC3200 that is used for doing multitasking and stuff. So we're going to do something very similar. What we want is actually create another task that will be very similar to the out-of-the-box task, except it's going to be MQTT. I want to call it MQTT task. What's the priority? Well, probably could use the same as OOB. Anyway, so that's my task. And now let's have a look by control clicking at the OOB task. What is CC3200 tasks and how does it look like? Well, it's basically a function that takes some parameters. So I want to build mine. I want an MQTT task, all right? So now, I don't want two of these. So now, first thing is, I'm going to do MQTT, right? So one thing I want to make sure of, and if you have a look at the code, you would see that there is this variable, this global variable that's being set to 0 whenever the internet connection is actually properly set up. Wi-Fi is on, you have a proper IP address and stuff. So I want to make sure that until my GEI internet access, while it's not 0, well, we don't have internet, right? So I want to wait until this is ready. So there is a function to sleep. I want to sleep for, say, 200 milliseconds, right? And from that point, I'm actually connected to the internet, and I probably can do some kind of infinite loop. While true, that is basically forever, I want to do stuff. And I want to do stuff, wait for a bit. Well, I think I said in the intro that we want to publish every second. So I want to publish temperature using MQTT. And so what is going to be there? Well, this is where we can use the code example that we've seen earlier in the Paho webpage. And this is basically these 10 or 20 lines of code. Copy, paste. So what's happening there? Well, maybe what we could do now is actually compile and see what's happening and how far we are from doing MQTT properly. Compiling, fingers crossed. Well, actually, of course, it's not going to compile. A couple of errors. Well, this one is actually should be easy to fix. tells me that LAN is undefined. I guess this is an issue with the sample that's provided on the Paho homepage. Let's try again. All right. Now that makes sense. Socket new is undefined. Well, socket new is undefined, and so is my sock, because actually this code sample is expecting you to provide your own socket, and socket new and write and close are probably functions that you need to provide, and depending on your socket implementation and the IP stack you're running on your microcontroller, this might differ. So this is where I'm going to actually replace these few lines of code with socket code from CC3200, right? The rest of the code, this is actually where I craft an MQTT packet. Like I want to use the MQTT library and the Paho library to craft a binary packet for MQTT. And once I have the packet in my buffer, then I want to write the buffer into my socket. So I need to create this socket, right? So socket functions on the LaunchPad are in the SL namespace, SL as in simple link. So what I want is to create a socket that, well, basically I want to create a socket. This is an internet socket, so I have this. I am in the inet domain. The type of socket is going to be a sock stream socket, sock stream, and this is irrelevant here. So I have a socket. Now I want to open my socket. So, and opening a socket is actually by using the connect primitive. So I want to connect. Oh, and I want to connect to a specific address, which I don't have just yet, right? So I will create an ADDR struct, which is going to be of type SL sock ADDR in. So this is my address. So now I need to set up a few things. Well, first the family. Again, this is AF inet. The port. What is the port I want to connect to? Well, default port for MQTT is 1883. And now what is the actual IP address I want to connect to? Well, I need to provide a long integer. And so what is the address I want to connect to? This is actually iot.eclipse.org. And so if you convert that to an IP address in decimal, the decimal for this IP address will be, and I'm going to actually input it in hexadecimal. This is C629.1EF1. No, I don't know this by heart. I have just a cheat sheet. So this is my address. Well, what else I'm going to use? What else I'm going to need? Yeah, this is supposed to be an SL sock ADDR. Probably going to need to cast here. So connection is all right. So we've basically, this is replacing this, all right? So forget about it. Now we need to replace this by the proper call to simple link, whatever. Well, this is probably going to be SL write, is it? No, it's not. It's SL send. We want to send. What is the socket we're going to write in? This is my sock. What is the buffer? Well, it's called buff. What is the length of the buffer? It is length. And the flags, we don't need any flags. So you can see that this is pretty similar, right? Send and write. It's basically the name of the function that's different. And closing the socket, how does it work? Well, this is SL close. Alrighty, what else? A couple of things I forgot is to make sure that we encode the port and the IP address using the network, right? There might be an Indianness issue if I don't convert the port to proper short, and the IP address to proper long, network long, hardware to network long. All right, is it compiling now? Almost. What? Oh, this was pointer to extract. Still not compiling? Come on. Let me have a look at my notes. Yeah, pointer. I love C. All right, this works. We could probably run the example right now, except that the payload should be our temperature, right? We want to send a temperature, and the topic we want to publish on could be something like CC3200 pen. Let's try this way. So now what we need to do is basically just replace this by the code that will allow us to retrieve a temperature. So how am I going to do that? Well, I'm going to have a look at how they do that in the sample code. Turns out that for reading the temperature, there is this this method that will put into a float the current temperature in Fahrenheit. So I'm going to basically copy paste this. Go back to my MQTT task, and what I want is copy paste. So temperature, blah blah blah, and I want to basically use this I2A method. So as I store in the payload, so I want to have a payload which is basically a buffer. All right, payload is a buffer. I want to make sure my buffer is properly initialized. I want to put zeros in there, right? This is meant to become a string. So let's put as many zeros as we need. All right, blah, blah, blah. PTR was part of the code sample. This is now payload. Do I want to add to appends blank F? Yeah, I probably want to do that. And PTR isn't PTR anymore. All right, it's, oh gosh, how I love C code. Compiling? Nope. What's missing now? OSI slip. I guess it's a typo there, right? Yep. This is compiling. Now let's run it. Okay. So right click. Well, we're gonna actually use this button over here. Debug. So granted that your board is properly connected, which might not be the case in my VirtualBox right now. Give me just a sec. All right, we are back. Yeah, not sure what happened. I'm running in the VirtualBox. So there's automatically a breakpoint at the very beginning. Let's skip the breakpoint. And now, hopefully, every second, the MQTT task is sending data to the internet. So now we want to verify that. All right. So what was the name, the gain of the topic I'm supposed to publish on? It's CC3200-pen. Let's copy that and use MQTT lens, I'm gonna post a link for you to install. This is basically a Chrome application that allows you to connect to a broker and see what happens. So how do you configure a connection? Well, you input the settings. In my case, this is IoT.eclipse.org broker. That's pretty much all I need. I'm connected, and now I want to see whether there are messages coming on CC3200 LaunchPad, and there are 86, 84, and if I warm up the sensor a bit, well, it goes all the way up to 96, it seems. So guess what? It's working. We are actually using the code from Paho, just tweaking it just a bit to use the socket implementation from the simple link stack, and we're done. So next we are going to try to actually subscribe to a topic.